So I'm going to commence my presentation now. I have about 35 minutes to get through quite a substantive deck. So I apologise in advance if there's an information overload. I don't mean to overload you with information. It's just that it is quite a technical topic. Both climate change and economics are relatively complex topics. So the carbon reward policy is a product of a non-profit, which I established about 12 years ago. And so what you're looking at in this presentation today is really the result of this 12 years of analysis. To begin, we should reflect upon the reality that standard policies or mainstream policies are inadequate. They're simply not getting us where we need to go with the Paris goals and a clean energy transition, particularly given the climate tipping points and feedbacks that Ben had described. So looking a bit more carefully at standard policies and approaches, I've listed some of the more well-known ones here: carbon taxes, cap and trade, regulation, standards, subsidies, fiscal spending, etc. And if we were to look at each one, what we'd find is that they are inadequate for a variety of reasons. So taxes and cap and trade, they're prone to political conflict and delay when attempting to scale. Okay, I think we're all aware of that. Yellow vest movement, protests, and so on. Regulations and standards, similar. Subsidies and fiscal spending, they're limited by fiscal constraints and the short-term priorities of governments because they only have so much money. Nationally determined contributions, prone to free riding and gridlock. Net zero pledges, these are non-binding when they're from corporates, and they often lack details. So you'll find that corporates and institutions will tend to backpedal on their pledges. Voluntary carbon markets and offsetting, they have weak carbon pricing, weak additionality, and zero-sum concepts. Climate bonds, whilst they do finance a lot of big projects, there is no real statistical correlation between climate bonds and the Paris climate goals. Debt for nature swaps, not scalable. So this is just a list to think about. There are other policies and approaches. So we have a gap between systemic risks and mainstream policy. We have urgent needs, and the carbon reward is offering a solution. So number one, in needs, we need climate finance at speed and scale to address the Paris targets and avoid these tipping points. So the carbon reward offers a scalable grant called a carbon reward, denoted XCR, and that would be available to market actors for a market-driven decarbonisation. Two, global political cooperation is missing. The reward is framed by carrot and stick carbon pricing. So it's not just the carrot, the reward, it's all policies together, sticks, taxes, and so on, to improve cooperation. And there's experimental evidence, empirical evidence, and other evidence to support a carrot and stick approach as being effective. A mechanism is needed to backstop the insurance sector and stabilise the financial system. As you could imagine, the insurance sector could collapse under the weight of global warming. So the XCR price floor would be guaranteed by central banks for rapid decarbonisation, and the XCR asset would help stabilise the financial system. I'll explain a bit about that later in the presentation. Number four, communities and ecosystems need support at the small scale, and adaptive XCR finance would be provided for community co-benefits and protecting ecosystems. So this decentralised problem is built into the policy. It's not just a top-down policy. By way of background, this policy was developed as an interdisciplinary study. So what I mean by that is that it's really a combination of the natural sciences with mainstream economics and central banking. And this is very important because in modern times, we have all specialized. You have your climate scientists, you have your economists, you've got your central bankers, everyone is specialized. And here, the approach is to really dig into the details of these three fields to integrate them properly. And so for natural sciences, very interested in the carbon cycle, planetary boundaries, the thermodynamics and physics there. Mainstream economics, very much focused on market theory of Arthur Pigou, Ronald Coase. And then in central banking, that field is actually quite mysterious in some ways, how central banks work, how the monetary system works, the mandates of central banks, and how they think. So each field has its own nuances and language and technical terms, and to really understand them all and bring them together is not easy. But the result is the carbon reward policy and an expanded economic framework, which I will introduce now. So from the natural science perspective, what we're doing here is we are considering the planetary boundaries from the perspective that they are really just a dashboard. It's a dashboard for civilization. You would look at each boundary and think of it like, metaphorically, like the dashboard on your car. You're driving your car and a light is flashing red. You might see the car is overheating. There's a problem. So what do? Well, you pull over, go to a mechanic. Mechanic checks the actual engine. So the metaphor for this problem is that the carbon cycle on the right-hand side is the actual engine. The boundaries are just the dashboard. So interestingly, in the planetary boundaries, most of them, I've denoted 6 here, are strongly coupled to the carbon cycle on the right. So we need to understand how the carbon cycle works. And also we need to appreciate that the planetary boundaries relate to all the main all the main biogeochemical cycles. So there's the carbon cycle, nitrogen cycle, phosphorus, sulfur cycle, water cycle. All of these cycles have common features, which I'll explain in a moment. But if we look at the carbon cycle on the right, you might recall from high school biology and chemistry that it's driven by photosynthesis. It creates the biomass pool from inorganic carbon on the left. So you've got the ocean pool of carbon, the atmospheric pool of carbon. It's converted into biomass. And then the biomass is naturally converted back to gas, CO2, through respiration, decomposition, fire, and combustion. Now what's going on is we're adding more carbon from the slow carbon cycle from fossil fuels, burning it, and adding more CO2 and methane to the atmosphere, which is heating up the planet through the greenhouse effect, and it's acidifying the oceans. Now, the point I want to make, I'll just reiterate, is that these 1, 2, 3, 6, 7, and 9 of the planetary boundaries, they're actually linked to the carbon cycle. And the carbon cycle is probably the most important cycle because it influences all the other cycles. And to understand it, we really have to come back to the thermodynamics because the carbon cycle is driven by thermodynamic potential of the sun, where photosynthesis is a non-spontaneous chemical reaction. It absorbs energy from the sun to create the biomass, the sugars, and then when that's oxidized, it releases heat back out to space. So it's these two complementary reactions, photosynthesis and respiration decomposition, are what's driving the carbon cycle. And all the cycles have similar complementary processes. So the point here is that on the left, you'll see this matrix. It's got yellow and blue, green boxes, 4 boxes. Those people watching who might be biologists or chemists or done a lot of study in the natural sciences, you might recognize it as the free energy matrix attributed to Josiah Gibbs. So Gibbs is a famous American scientist who published this rule, the free energy rule, delta G equals a change in enthalpy minus T times change in entropy. So these technical details are too detailed for our presentation now. What I'm trying to explain here is something quite simple. That is, this matrix on the left, it's foundational to chemistry and biology. Basically, it is the foundation of chemical thermodynamics in that it explains that certain changes in energy and enthalpy imply that some reactions are spontaneous whilst others are non-spontaneous. And the point is that photosynthesis and CDR, carbon dioxide removal, are generally non-spontaneous, meaning they need an energy source, an external source, and that's provided by the sun, otherwise it wouldn't happen. And then the respiration, fire, decomposition, and so on, they are spontaneous because the energy is contained in the chemicals, in the chemical bonds, and that energy is released as heat. So for those who aren't familiar with these concepts, I just want to remind you that, or let you know that this is fundamental, and this is the approach that I've adopted to go back to the fundamentals of chemical thermodynamics. Now, this slide here illustrates a potential breakthrough in economics. For the first time, this matrix approach is actually being used to understand the economics of climate change and carbon pricing. So it's a bit difficult for me to explain this properly just in a few minutes, but I'll attempt to do that by just easing you into the concept without going too far in the details. So we focus in the middle matrix. That's me actually, there just to clarify. What I've done is I've taken this matrix and said that it actually can be used to describe patterns that emerge in complex systems. And the way it works is that if you have a complex system with two attributes, major attributes, and they have opposing possibilities, say attribute A could be something like a high value and a low value, or opposite values, say spatial scale or carrots and sticks, or anything that's opposing. And similarly, attribute B has a different pair of opposing values. Then if they're additive, what you'll find is that you'll have a class of outcome, denoted 1, that's opposite to class 4, the blue box. So class 1, class 4, opposite, and there are 4 classes in total, 1, 2, 3, 4, and classes 2 and 3 have mixed outcomes. Now, the logic behind this is not complicated, but interestingly, this matrix has not been used previously to analyze the economics of climate change. Now, it just so happens that it's exactly the logic behind Gibbs's free energy matrix, and I've used it on the right to analyze carbon pricing for addressing the climate crisis. And this is where the breakthrough happens, because this matrix, this 2x2 outcome matrix, it enables us to delineate the 4 major policy types that are possible. So the rows denote the incentive strategy. There's either sticks or carrots, and the columns denote the internalization strategy, either using currencies or carbon assets. Now, I'll just quickly explain the internalization strategy. For those people who are interested in economics and policy, you may know this. You would know Arthur Pigou and Ronald Coase, but for others, it might be a foreign concept. But basically, Arthur Pigou's theory is the groundwork or foundation of neoclassical economics. And he says that you can correct a market failure with a tax or a subsidy, that's 1 or 3. But Ronald Coase came along and said, hold on, we don't actually have to use fiscal accounting from the government. We can also solve a market failure by creating assets in cap and trade, it's emissions permits, and then you assign them to polluters and let them trade. So they trade the permits to discover a price, and this is another way to correct the market failure. Now, an important point is that the economics textbooks don't actually present these policies in this matrix format. This is the first time it's been done. And it identifies, number 4, the carbon reward. So the carbon reward is also called mitigate and trade, and it uses the Coase theorem, and it uses a new type of asset called a carbon reward, and it's not a carbon credit. So I'll just quickly summarize why this is important. It might not be obvious why this is important, but believe me, it's incredibly important, because for the first time, we potentially have a bridge between the natural sciences on the left, which refers to all the biogeochemical cycles of the Earth, and mainstream economics on the right, literally connecting them together through a structural analog. And the paper I've written and published explains this and verifies it and validates it. Now, I'll just also comment that because it does such a bridging, it really fundamentally changes or adds to the philosophy of economics. Because economics as a field, it began in the 1700s, people like Adam Smith trying to understand why do we have prices, what is value. And then in the 1700s and 1800s, there was a marginal revolution where people realized, economists realized, that prices are established through supply, demand, and marginal utility. It's marginal utility. And here, why this is so fundamental, it's saying that we can then define prices again with more fidelity to differentiate prices that linked to spontaneous chemical reactions, combustion, and prices linked to non-spontaneous, which would be photosynthesis and carbon dioxide removal. So we're actually framing pricing again with direct references to thermodynamic potential. And so in this slide, we just want to think now about what are the implications in terms of economic optimization. And so to complete the analysis, we need a reason for a carbon reward. We know that from Pigue's work, it's the negative externality that defines the social cost to carbon and is the purpose of the carbon tax. Cap and trade does a similar job with slightly different outcomes, but the deeper meaning behind the carbon reward and its link to the carbon cycle is that it's needed to correct a completely different type of externality. So my claim or my thesis is that mainstream economics is missing what I call a systemic externality. And this is quantified as the risk cost of carbon. And so through this approach, through this theory, we're able to address two problems. The traditional negative externality, which is a cost management problem, and then systemic externality, which is the risk management problem, using different instruments. Now, I'll just continue. Watching the time, we've got plenty of time. So let's have a look again at this concept of the risk cost to carbon. And what does it mean? Well, what I claim, it's the cause of this risk cost, the systemic externality, are societal systems and climate dynamics. So societal systems actually pose a systemic risk. Because why? Well, if we look at figure 1, what this diagram is trying to explain is that, by metaphor, we are like birds trapped in a cage, that is, market actors, society. The cage represents all the different societal systems, like the financial system, the laws, the banking system, how money is managed, interest rates, culture, cultural expectations. All of these networked invisible forces out there actually limit our choices, and such that it creates a political lock-in that restricts the utility of Pigue's policies, the standard market policies, and thus societal systems create risk. Figure 2, it explains it a bit more dynamically. What it's saying is that when we emit greenhouse gases, obviously the Earth warms up, creates damages. Then 2, the economists estimate social cost to carbon, and the SCC will increase with warming. And also, as our scientific knowledge about the climate system improves, we realize the damages are worse than we initially thought. As tipping points come closer and become more clear, the SCC will increase in response. So number 3, as taxes need to rise, as regulations need to become more stringent, as costs increase, as assets become stranded, there's more political resistance because market actors don't want these costs, and so they try to preserve the status quo. And so as the political barriers prevent carbon taxes, etc., we're back to one, where more greenhouse gases accumulate in the atmosphere, climate change worsens, the social cost of carbon increases again, it just goes round and round. And so this is called the self-reinforcing cycle of inaction. And the point is, Pigue's theory, which is 100 years old now, doesn't actually take this into account. Earth systems are also a cause of systemic risk, and we need to understand why. So I'll just go through this very quickly. Ben described tipping elements or tipping points. Essentially, what I'm saying is that there's a lot of complexity in Earth systems and the climate. It's incredibly complex at different scales, lots of different processes. So scientists can't actually model everything accurately. They have to develop models through time with new data. They have limitations with the granularity of models and so on. And so we'll always find that there are things we don't know. And as feedbacks increase and tipping points approach, we learn more about it, and then we make more accurate predictions. So this uncertainty, the climate feedbacks and the tipping points, what they represent is a systemic risk because they will almost always turn out for the worse, unfortunately. Now that I've covered the cause of the systemic externality, this slide is just to summarize the key points. So on the left, we have the notion of Pigue's negative externality and the social cost of carbon. What is it? Well, it's the unpriced cost imposed on third parties who are not involved in the transaction of goods that generate carbon emissions. The social cost of carbon refers to the average time discounted marginal damage caused by a tonne of carbon emissions, and the ideal policy is a carbon tax set equal to the social cost of carbon. For most regular people, that probably doesn't mean anything, but for economists and policymakers, they would know exactly what that's saying because it's standard theory in the textbooks. The probability distribution down the bottom is similar to the one that Ben presented. And basically, what it's saying is that the social cost of carbon would aim for the mean value because Pigue's approach is about economic or social efficiency. So naturally, you can only price with one value. You go for the mean damage, and that's the social cost of carbon. In this expanded framework, I actually claim that it's not a regular market failure. We're actually dealing with a special case I call a market and system failure. Why? Because it has the systemic externality and the risk cost of carbon. So what is it? It's the unpriced cost of managing systemic risks to the carbon cycle, where the risk is caused by societal systems and Earth systems. The risk cost of carbon refers to the average marginal cost of 1 tonne of carbon dioxide removal, sufficient to limit the systemic risks. The ideal policy is a carbon reward set above the risk cost of carbon. And very quickly, I'll just summarize what it means. What it means is that if we don't have the carbon reward, or something similar to it, the probability distribution for damages will tend to move to the right-hand side. And from time 1 to time 2, it'll become flatter, there'll be a fatter tail, and that's because we're unable to limit emissions and we're approaching tipping points. So it's a very dangerous outcome. And what the carbon reward would do is help constrain this probability distribution and allow us to use taxes with more confidence. All the theory and the policy is explained in this working paper. It's free to download from Zenodo. Just Google it. The title is Carbon Reward Policy and Economic Framework for Responding to Climate Damages and Systemic Risks. It's 160 pages, very detailed. It's got appendices which go into even more detail. So I do recommend you read that. Now I'm going to spend the last 10 or 15 minutes describing the actual policy. So we left the theory behind. You're probably thankful for that. Now we're going to actually look at the policy and just explain what it means in practical terms. So in practical terms, we want to mobilize trillions of dollars. To fill the climate finance gap, we're going to need an additional $3 to $6 trillion per year or more. And the way it's managed is that we have three concepts. On the left, a grantor. It issues the XCR. It's called a carbon exchange authority. It supplies the reward to the marketplace. They manage the registry, the rules, using long-term contracts. So that's supply of XCR. On the right-hand side, we have the guarantor and investors. So the guarantor would be the world's central banks joined together in an alliance. They would be mandated to act as buyers of last resort. They guarantee the price floor, and through their actions, they encourage the private sector to invest in it. So we're actually encouraging investors to buy it, and so the cost of mitigation is channeled into the private sector and the financial system. If you consider on the left, we have supply, on the right, we have demand. It's the interaction that discovers the price, and that's managed in the foreign exchange market. So there will be a settlement system in the foreign exchange, noting the foreign exchange is the largest and most liquid market in the world. It regularly transacts trillions of dollars every day. The XCR is not a currency, it's just a store of value. It would be registered officially, and the best analogy for it that exists today would be XAU, which is gold. If you could imagine paper traded gold on the foreign exchange, it's very similar actually to this asset that represents carbon. Okay. If we're going to solve the climate problem, address the Paris goals, obviously we need to keep our eye on the mitigation roadmap. And that's what this diagram is explaining. You may have seen diagrams like this before. It's the projected total greenhouse gas emissions for the whole world for about 75 years to the future. So imagine the carbon rule policy begins around here, say 2025. The top of the white area represents where we would go with existing policies, but we need to actually follow the blue, which is a much steeper curve going down, to stay within the Paris targets. So all this white area in the chart needs to be avoided with conventional mitigation. Okay, so this policy funds as much of that as that's needed through Reward Channel 2. So Reward Channel 2 is to fund conventional mitigation across all sectors of the economy, all industries that need support. Now let's turn our attention to the yellow down the bottom. What does that mean? If we want to achieve the Paris goals, we really have no choice in that we would have to take carbon out of the atmosphere. It's called carbon dioxide removal and storage. Why? Because probabilistically, it'd be impossible for the world to achieve gross zero emissions. We'll always have residual emissions, whether it's some fossil fuel burning, land management, chemical processes. We're always going to emit something, and thus we need this in the long term and to address overshoot. So that's why Reward Channel 1 is there. It explicitly prices carbon dioxide removal and funds it. Reward Channel 3, this is a third channel to deal with co-benefits that are specific to communities and ecosystems. So people would have heard about just transition and co-benefits. This policy is designed actually to support communities and ecosystems to help stabilize them, because if communities are incoherent and if ecosystems are breaking down, it makes it very difficult to stabilize the carbon cycle. So this channel, I won't describe here now, but it can just invoke grassroots reward concepts and top-down concepts that are built into the whole policy. So we're just going to have to skip that for today's presentation and focus on channels 1 and 2. So just keeping your focus on channel 1, we go to the next slide. What you're looking at here is the price floor, the XCR price floor for mobilizing finance. This may be confusing at first. If you don't really understand it, don't worry. It's not that easy to understand at first. It's explained in the paper. What you're looking at is the estimated price, average price for carbon dioxide removal to achieve the Paris goals. So it's the minimum safe rate of CDR that we'd need, and that's how much it would cost, approximately. And that's how we define the price floor. And the price floor would be guaranteed by central banks. So the central bank alliance, the buyers of last resort, would use a method called carbon quantitative easing. Zen mentioned that at the very beginning, carbon quantitative easing. And that's a form of QE that's strategic, long-term, and specifically to defend the price floor. The XCR, when it goes into the foreign exchange, it will achieve a price that's a product of supply demand, and so that's the spot price, shown as the red squiggly line. And the spot price will always stay above the floor. If it threatens to fall below the floor, then central banks step in and buy it up until it goes back up above the floor, and that's how it works. So the important point is there is no cost for government, no cost for businesses or households, because we internalize the cost into the global financial system. Okay, now we can think a bit about Earth observations and start to talk about satellites and things like that. So part of this policy would be the need to issue long-term contracts to awardees, so to projects. And I just have an example here to give you a kind of contextualization of how this would work. So the example is keeping fossil fuels in the ground. What we could do is, for example, buy oil, an oil field, buy it from the owner, an energy company. We pay them carbon rewards, and we get the owner to sign a contract where they leave the fossil fuels in the ground and instead build out a solar plant with using the reward finance. So imagine they do that, and they're going to build out a large solar plant. This is a very long-term project with high capex. So our contract will take note of all of the establishment milestones. Say from year 1 to year 5, there would be feasibility studies, development, permitting, financial approvals, and construction. So those milestones can trigger reward grants, okay, part of the contract, to help the project fund its high capex start. And then over the years of its deployment, as it produces clean energy, we would monitor with satellites, drones, field inspections, keeping an eye on the amount of clean energy produced and performance. And this could go on for decades because that's how long energy projects tend to last, at least 30, 40 years. Then beyond that, for another 100 years or more, there would be measurement, reporting, verification to ensure that the oil reserves are actually left in the ground. So this is the nature of the long-term contract, and this would be applied for every sector of the economy and every industry, but just having different details. A key point is that this policy is very flexible because we can offer rewards ex ante during milestones and then ex post of mitigation when performance is measurable. Okay, I have maybe 5 or so minutes left. I'm coming towards the end of the presentation, so just hold on. This slide is to summarize the operational use of satellite services in particular, and also remote sensing of other kinds. But here's where the opportunities for Digital Earth tend to shine. So keep in mind that if the carbon reward were implemented globally, the market would approach $3 to $6 trillion a year. That's the ballpark figure. By comparison, it's equivalent to about the size of France's whole economy. The GDP of France is of a similar size. So that's how big this market would become. So of that, roughly close to $1 trillion would be spent on administration and measurement, reporting, verification of all kinds. For Earth observations, that means we would need baseline monitoring to understand what's happening in the past, to establish additionality. There will be milestone verification, so observing projects as they're constructed and deployed. Performance tracking, long-term MRV, measurement reporting verification, so we would need to measure and monitor the emissions and all the activity on the ground. We would need early warning systems, such as detecting the risk of forest fire, or maybe there's wars or social unrest, or there could be any kind of environmental stress that threatens a project. Data integration, very important, because we diffuse the different types of data from satellites and ground truthing to validate and confirm the information. We would need automation of these processes because there's so much data. We might use, say, smart contracts or AI to assist with the analysis. And then there are specialized services such as forecasting, forensics, and dispute resolution, which would also be required in such a large market. What is the implementation pathway for the carbon reward policy? And would you like to support the initiative? Well, to understand, we do have a theory of change that's got 3 steps, immediate steps. The first is we're setting up our own working group that will review the policy, provide strategic advice, build support, and we have to raise funds for the next stage, which is the feasibility study. That's our main mission this time. For the ISDE, it may be that the ISDE would like to set up a task force that's aligned with its Digital Earth Framework 6, which Richard will talk about. It would have to be defined under an ISDE mandate, define deliverables, and it would need to align with the ISDE's own governance model. But that could feed into the project. Once we get to feasibility study, if it's funded, we would be doing a variety of assessments, which I'll describe in a moment. And then a successful feasibility study will attract countries to do pilots. And this is where the policy would really begin to be well known around the world, because the pilots would be set up by countries, not just as proof of concept, but really to advertise the policy. Because I'm fairly confident, we're fairly confident this policy would work. It's just that it's so new, the world doesn't really know how to relate to it. And the pilots and the feasibility study will communicate to the world what it's all about. If you're interested in this, just contact me and I can give you more information. But in terms of the details, basically the feasibility study, what it will do is interview the captains of industry, especially in these sectors that produce emissions. So we'd interview, the executives of major companies that are emissions producers, and we would role play with them and ask them, would they participate in the policy? Would they decarbonise quickly with this additional grant funding? The pilots that we recommend are energy asset exchanges, because they're incredibly important for a transition away from fossil fuels. I described one already in the long-term contract. Avoided deforestation would be incredibly important, because it would illustrate how we could protect the Amazon over large scales, at the size of bioregions. Carbon dioxide removal, of course, this would directly finance carbon dioxide removal. Hard to abate transport will be a good example. You have shipping, you have aviation, very difficult and expensive to decarbonise. There's a lot of resistance there to decarbonise quickly. And carbon intensive buildings, that would be a great example, because everybody lives in a building, and there are so many buildings in the world that we could illustrate how it works for a community somewhere. So that's the end of my presentation. We're actually on time, almost. And I just want to conclude by inviting you, if you want to support this project, we really do need support. You could review the policy. You could contribute to a task force, join our working group, or support in any way you like. Just reach out through the emails or contact me. So that's the end of my presentation. Thank you very much.